So up next, pre-cal, we're going to talk about understanding the concept of a limit and estimating limits from graphs and tables, but again, in kind of by direct substitution as well. But this time we're going to be doing that with those unbounded limits we've seen, but we're going to get a little more specific when we classify them. Now, unbounded limits are still technically non-existent, but sometimes we care to classify them a little bit more precisely. So make sure you remember your notation. I'll talk through it, but hopefully this assignment goes by pretty quick. So we have this graph here that clearly has some horizontal and vertical asymptotes. Let's see what goes on here. It says the limit as x approaches, remember this means 1 from the left, so here's 1. And from the left, we're approaching, well, unbounded, but we're going up, 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 up. And remember, up is positive. So as we're approaching 1 from the left, are we approaching positive infinity? Yes, we are, but this says negative infinity, so don't click answer choice A. This one says negative 5 from the right, so let's find negative 5. Here it is. From the right, the limit is going up, 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 up to positive infinity, so yes, check it off. What about the limit as we approach 3? Well, here's 3. The limit as we approach 3 is, I don't know, 2.8, so don't click that one. Cool. And we'll just do this a few more times to get the idea. Okay, this one's a little bit different format. It's saying, okay, the limit is 0 from the right should be going towards infinity, and choose all the graphs that agree with that. Okay, well, as I approach 0 from the right, I'm approaching 1/2 or something like that for A, so don't click that. As I approach 0 from the right, I'm going down, so to negative infinity, so don't click B. And as I approach 0 from the right, well, I'm going up forever, so yes, that does agree that I'm going up to positive infinity. So I'll just do that a few more times, and we'll move on to the next assignment. So hopefully this one goes by pretty easy. It's the notation that's a little bit difficult, that's why I'm saying it every time. Make sure you're hearing what I'm saying. So again, I've got a crazy looking graph. Don't freak out, we got a lot of vertical asymptotes. Let's see what it says. The limit as I approach negative 1. Now that means the left and right have to both be going to negative infinity, have to both be going down. As I approach negative 1 from the left, I'm going up. As I approach from the right, I'm going down. So they are both not going down, so don't click A. Okay, what about 3 from the right? Is that going down forever? 3 from the right-hand side, yes, is going down forever. What about negative 5 from the left? Is that going down forever? Well, negative 5, the left-hand side, is actually going up forever. As you approach negative 5, as you get closer to negative 5 from the left-hand side, that's going up forever, so no. Okay, just a few more times. As I approach 3 in general, which one approaches infinity? Well, again, 3, now the left and the right are both going up, positive, so yes. What about this one? Left and right, yes, both going up. Left goes up, right goes down, so don't select C. So should select A and B, don't select C, and well, I guess I'll finish this up. Okay, 5 from the left, that goes up forever, so yep, positive. 1 in general, well, from the left it's up, from the right it's down, so no. Negative 7 from the right, yeah, that does go down forever. And negative 3 from the left goes down forever. 3 from the left, down forever. 3 from the left, down forever. 3 from the left, up forever. So only A and B. And that's it. Okay, let's move on to our last one, which is infinite limits algebraic. Now this is where things are going to get tricky. But at the end of the day, it's direct substitution. So here is the cheat, so to speak. If you're asked about the limit of negative 2 from the right and from the left, think either negative 2.001 or negative 1.999, because those are super, super close, or at least close enough to negative 2 to understand what's going on. So let's also just talk about this. All of these are saying negative 2 from the right. Now think about the number line for a second. If you are to the right of negative 2, you're actually going to be like negative 1.999. So for this first part, let's figure out if I plug in negative 1.999, is this whole thing going to be positive or negative? Now the way to do this is think about it as only a numerator and only a denominator and combine the signs. So what do I mean by that? Well, here we go. 3 times negative 1.999. Again, I'm figuring out what the limit is on the right-hand side. And notice I'm just directly substituting. Oops, plus 2 squared. Okay, this problem has some special things going on here. Number one, 3 times a negative is, now if you say this is pretty much negative 6. Okay, this is essentially negative 2. So 3 times essentially negative 2 is essentially negative 6. Now on the bottom, this is some very small number, and it's being squared. Now think about this, whenever you square a number, regardless of whether it was negative or whether it was positive, it ends up being positive. So I'm just going to put over positive. So in other words, I know that this is negative. Okay, so what is this approach? Well, what's a negative over a positive? A negative, so I know it's this. I know it has to be C or D. In other words, negative 2 from the right is going to be negative infinity. Now, just to make this a little bit more clear if you're kind of lost at what's going on, let me just use the calculator to show you precisely what's going on here. If I do divided by parentheses, okay, so I get a really, really big negative number. Okay, what if I gave myself an extra decimal place for both of these? So if I insert an extra 9, insert an extra 9, wow, all right, an even bigger number. So you can see as you get closer and closer to 2, you get a bigger and bigger negative number. So as you approach 2 from the right, you're getting a large negative. So we know it's C or D. Now the question is, what's happening on the left-hand side? Well, let's investigate that. If I'm on the left-hand side, all right, that's going to be essentially like plugging in negative 2.001. Okay, now again, what goes on here? Now I'm still kind of like, not cheating, but this is essentially still negative 6. Now this is a very small negative, but it's being squared. So a very small negative squared is still positive. So I'm still getting negative over positive, that's negative overall. So just trust me if you use a calculator. Well, actually don't trust me, I'll do it for you. If I do the same thing with negative 2.001, oops, 001, 2.001. See, look, I still get negative, a very big number, and as you add more zeros in between that 001, you're still going to get larger numbers. So from the left and the right, you're approaching negative infinity. So which one it says from the left or the right, they're both going to negative infinity? Only answer choice D. Now again, specifically, here's the wording, I'll say it for you, and then I'll move through a little more quickly. This says the limit as you approach negative 2 from the right approaches negative infinity. This says the limit as you approach negative 2 from the left approaches negative infinity. So just be aware of that. So let's move a little more quickly. Let's look at this example. This is definitely a cruel example, but you have to remember trig, so at least we're covering this together. All right, now I'm also just saying, we're in a wonderfully unique time here. We could also just go to Desmos again. Now, if you're planning on taking calculus, you want to do that algebra approach, but at the same time, let's look at this graph. As I approach negative 1, here it is, from the right is going down forever. Negative 1 from the left is going up forever. So negative 1 from the right goes down, negative 1 from the left goes up. I know the answer is C. Now let's talk about how we get that. So I'm just saying, feel free to use a graph during this crazy COVID time, but if you're planning on taking calculus, you should also understand what I'm about to do right here. So again, the same thing. If I approach negative 1 from the right, I'm going to be like negative 0.0 or negative 0.99999. I'm almost negative 1, but I'm closer to 0. So what do I get when I plug that in? Well, I get negative 0.99999 over 5 times, well, sine of negative 0.99999 plus 1 is actually just 0.001. Now the thing about sine, here's what you need to remember. Sine is a y value, so if you actually plug in sine of a positive, very small y value, you've moved to like that far. Okay, now that y value is still moving up though. So this is essentially a negative over a very small positive because you have 5 times a positive number. There's a lot going on here. But that's the idea. You have essentially -1 over a very, very small positive number. That's going to bring you to negative infinity. So 5 from the right goes down forever, and the graph agrees with that. -1 from the right goes down forever. I was thinking about the 5 out front. Okay, let's talk about the left-hand side. From the left-hand side, I'd really be at -1.001, essentially. That's really going to be, if you plug that into the sign and simplify a little bit, it's going to be sine of -0.001. Now what happens there? Well, you still have a negative number over a very small, now think about this, when you plug in sine of -0.001, you get a negative number, very small negative. Same amount, just moving downward. So 5 times this very small negative number is again a very small negative. Now essentially -1 over a very, very small negative is going to be, positive infinity, because you have a double negative. Double negative turns into positive. So you essentially have -1 over, I kind of sometimes say very small. And you can kind of think about what that means. It means as you get close to -1 over very small, see, you get a actually big number. In other words, if you have to divide -1 into super, super tiny pieces, you'll be able to divide it into a lot of tiny pieces. So same idea. A negative number into negative tiny pieces actually gives you a positive amount of a lot of tiny pieces. So there we go. All right, moving more quickly. Now this is a little bit different. It's a little simpler. Just 3 over x as we approach 0. Now again, think about this. Here's 0, here's -1, here's +1. If we're approaching 0 from the right, we're going to be positive, so just 0.001. Now if that's over 3, again, you're dividing 3 into positive, very, very tiny pieces. That's going to be positive, a lot of tiny pieces. So either A or B. What about as we approach this from the left? 0 from the left means we'll have -0.001 substituted into the function. And that will be negative infinity because you have a positive over a negative. So which one says positive from the right, negative from the left? Answer choice B says that. And last but not least, again, we've got some wackiness going on here. Sorry, there's so much trig. I wish I could control these questions. Okay, positive 2 from the right is going to be 2.001. That's over 1 minus essentially cosine of, if it's 2.001 minus 2, it's just 0.001. Okay, things to know about cosine of 0.001. This is actually really advanced. So cosine of 0.001, you've moved this far, but the question isn't how far up did you go. Cosine says how far right or left. Now if you remember cosine, if it moves all the way, it's moving 1. So this is moving a little bit less than 1. So what's 1 minus a little bit less than 1? Well, it's a positive, very, very small amount. So all right, positive, very small. If you divide 2 into positive, very small pieces, you get a lot of positive, very small pieces. Okay, so from the right, we should be getting positive infinity, so either A or B. Let's talk about the left. If we're going left of 2, that's 1.999, very close to 2, but on the left-hand side of the number line of it. Now 1 minus cosine of, essentially that'll work out to -0.001. Now this is kind of tricky, but if you go left, how far right did you go? Actually the same amount. So if you move downward, so negative radian, you're actually still moving right the same amount as when you moved up positive. So this is actually still essentially 1.999 over, this is 1 minus cosine of something a little bit less than 1. So 1 minus something a little bit less than 1 is a positive, very small. So again, if you try to divide essentially 2 into positive small pieces, you'll get positive infinity. So the left and the right go to positive infinity. Now again, if you have a graphing calculator or any calculator, this is totally fine. To do this, just plug in 2.001, divide it by, and plug in the whole thing. 1 minus cosine of, and it was 2.001. Make sure you always have the same amount of zeros. That can totally change the answer if you disagree on that. So see, look, I get a very, very large positive number. What if this was 1.999 instead? 1.999 and 1.999, so I'm at the left of 2. So you still get a very large positive number. Again, you can plug it into Desmos and see that kind of behavior going on as well. So that's it.